Hi, class. Hope you guys are excited to learn some math today. Today, we'll be learning about the 6.1G lesson, and it is on the sum and differences of square roots. Uh, Overlooking this entire lesson, it's a decently long lesson, so I'll be making 3 videos again, like last time. But just remember that this is one of the most important topics that we've learned in this module so far. So please take notes carefully and be sure to pause whenever you feel comfortable or whenever you want, basically. And let's get started. So it says, Joy explains to Laura that the expression 3x plus 2y simplifies to 5xy. Is Joy correct? Explain why or why not. Okay, so this is something we've learned since we started learning about pre-algebra and algebra. We know that 3x and 2y are not like terms. We also know that we're adding here, right? So there's no way that we should be ever combining these two and forming one term. 3x plus 2y is simply just 3x plus 2y. So Joy is incorrect. When adding, the terms must be like terms in order to be combined. Okay, we know that if they are not the same term, like x and y are different variables, then you cannot combine them, right? So this concept is also true for radicals and square roots, and any root for that matter. So for number 2, it says, Laura explains to Joy that the expression 4 radical 5 plus 3 radical 5 simplifies to 7 radical 10. Is Laura correct? Explain why or why not. Okay, so I can see why Laura believes that 4 plus 3 gives you 7, and radical 5 plus radical 5 gives you radical 10. But we also have to be very, very careful here. So I'm just going to give you a quick example. Do you believe radical 1 plus radical 1 is equal to radical 2? Well, let's take a look. Radical 1, or the square root of 1, is simply 1. And 1 plus another square root of 1 is the whole number of 2, not the square root of 2. This is a very, very simple example, but it just tells you that you cannot add square roots like that. You can multiply square roots like we did in the previous lesson, but the square root of 1 or the square root of 5 and the square root of 5 for that matter does not give you the square root of 10. Okay, so that's one thing. You cannot add these two numbers. Instead, what you have to do is you have to think of it as like a variable, right? It's kind of like I have 4 square roots of 5 with 3 square roots of 5. So how many total square roots of 5 do I actually have? Okay, so we realize that Laura is also incorrect. Square roots cannot be added to form a larger square root. Instead, simply just add the value, kind of like the coefficients class. You just add the coefficients or the number in front of the square root together, and then you leave the square root alone. Simply just add the values in front and keep the same root. Okay, that's a lot that I'm writing right now. I hope that makes sense. So the answer here is simply just 7 square root of 5. Okay, the square root of 5, another quick example is the square root of 5 plus the square root of 5 is simply 2 square root of 5. It's kind of like saying, how many square roots of 5 do I have? Right? I have 2 square roots of 5. Uh, Now, you cannot combine things unless they are the same exact number. So the square root of 5 plus the square root of 7, for example, you cannot combine them. It's just like saying, what is x plus y, right? They are different terms. They cannot be combined. Okay, I'll do more explaining of that when we continue with this lesson. Okay, so we're going to start off with some easy examples. Number 3, it says to simplify 2 square root of 2 plus 4 square root of 2. We have the same square root. So same value under the root, which allows us to then combine, I don't want to say coefficients, but we can combine these numbers in front, right? Coefficients by definition is the value in front of a variable, but this is very similar to adding like terms. We add the numbers in front of the square root. So we say 2 plus 4 is going to give us 6. And then we don't do anything to the root. It's just the label, right? So 6 square root of 2 is my final answer. Okay, here we have 5 square root of 6 plus a singular square root of 6 minus 2 square root of 6. So it's kind of like, let's just start with this. What's 5 square root of 6 plus square root of 6? That's going to give me 6 square root of 6. And then you subtract 2 square root of 6, and you end up with 4 square root of 6. Okay, again, we have the same value under the root. We don't do anything to this term. It's kind of like a representative, and these are how much of each that we have. Okay, so for number 5, you can see how they're starting to get a little bit more challenging, right? This is the square root of 2. It's simplified. This is the square root of 8. It's not simplified. So obviously, we would have to simplify this first, and then we could see if we can combine. Sometimes we can combine. Sometimes we might not be able to, but that's okay. If anything, let's simplify. So hopefully from the previous lesson, you're getting more and more comfortable simplifying something like the square root of 8. The square root of 8 is decently popular, and you end up almost memorizing it. Square root of 4 is going to be 2, and then the square root of 2 is just 2, or square root of 2 is just itself. And then you get square root of 2 plus 2 square root of 2, and you know that it's 3 square root of 2. Okay, so it's kind of combining all of the things that we've learned so far from the previous lesson, and now we're asked to add and subtract square roots. Okay, so I think the key here is always simplify radicals first, and then combine like terms. Okay, notice how we simplify square root of 8 first. We got it to be 2 root 2, and then you get that to be 3 root 2. Okay, so something like number 6 has there's 3 different things. We already know that 7 square root of 2 is simplified, so that's good. Let's go ahead and simplify square root of 18 on the side, and with more practice, you realize that this is going to be 3 root 2. That's a good sign because we want it to be the same as the square root of 2. And then we also have 3 radical 8. So I'm going to simplify square root of 8, and then I'm going to combine it with that 3. This is just like the previous one from the last example, right? And you don't really have to show all this work every single time. You can almost kind of like copy and paste this 2 root 2 from there if you really want. But the thing is, we cannot forget about that 3 in front. So you have to put times 3. And I'm going to rewrite the entire field now. We have 7 square root of 2 minus 3 square root of 2 plus, and this is going to be 6 square root of 2. Okay, this is exactly what we want to see. They all have the same exact square root. So we just do 7 minus 3 plus 6, which gives us 10 square root of 2. Okay. Let's take a look at number 7, square root of 135. Wow. Sometimes it's not the easiest to identify what square root is a factor. But one clue here is the fact that this is a square root of 3. So you almost want to say, like, should I just use square root of 3 as a factor? It's kind of like a good guess. I don't know off the top of my head what is a perfect square that's a factor of 135. So let's just write down the perfect squares again. So you have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And you can kind of stop right there if you want. You can keep going if you really want to. 96, and then obviously we have 225 if you really want to show that one. Okay, and then now here's my strategy again. I go to 135, and 135 is in between 121 and 144. So then I just go, okay, which one of these numbers could potentially be a factor? Obviously none of them. 64, no. 49 is no. None of these actually work because it does end in a 5. So I'm thinking of 25, but 25 is kind of clearly not a factor of 135. So it really just boils down to, does 9 work? What times 9 equals 135? Square 9 times, well, what's 9 times 15? Oh, that's perfectly the value, right? Why did I use 15? Why did I think of 15? Well, because it ends in a 5, so I have to use either a 5 or a 15. There's really no other option. Okay, so this becomes 3 root 15 minus 2 root 3. And you might say, wait, what's going on? Is this supposed to happen? Well, I think the point of this question was that we just wanted to make sure you realized it's okay for things to not actually, simplify further. It's kind of like x plus 2y, right? If you have x and y and you can't do anything to make it simpler, then that means you're done, right? So 3 square root of 15 minus 2 root 3, I believe that's the final answer. Okay, let's do one more. This one just seems like it's decently time intensive, so just be careful and try to avoid careless errors. Okay, so I'm going to slowly simplify each of them. We have a 6 on the side, and then we have a square root of 45, so I know that that's square root of 9 times square root of 5. I also know that this is 3, so I know that it's 6 times 3, which is 18 rad 5. Okay, I'm going to use another color so you know exactly what I'm doing. Square root of 320. Wow, that's a big number. That's why it's nice to have these perfect squares on the side. 320, I kind of already see it. Hopefully you see it too. There's really no point in using these large numbers because there's no way that they can be factors. 121, 100, 81, 64 definitely looks interesting because 4 times what equals 20, right? So that's kind of what you have to have your eyes